Hey, Matt.
Hey, Mike.
I got a good idea for our podcast episode today. You ready for an adventure?
I love adventures.
All right, let's do it.
Adventure.
Welcome to Hacking the Grepson. Today on the pod, can't believe I just said that. I'm going to edit that out. I won't edit that out.
On the cast.
We are doing, it's your boys, Mike and Matt here with another episode of Programming Prowess. I'll cut that out too. I won't cut that out. Nope, I'm not going to cut any of this out. We are currently in December of 2025. That means Advent of Code. Our last episode, we talked about the first 6 days. And today, if you are using the normal Arabic numeral system, the number that comes after 6 is 7.
6, 7.
6, 7.
Yeah.
Yep. We both have kids. We know what that is. Okay. So we wanted to do something that we did try once before in the past, but we're going to try it again. We have not looked at day 7 of Advent of Code 2025. I have the website up, and I'm ready to click and look at it, and we're going to see if we can make heads or tails of day 7 together right now.
Okay. Tell me when I should look.
All right, moving the cursor. It is highlighted. 7 has been hovered. I'm clicking now.
All right.
Oh, boy. Oh,
Laboratories.
Hey.
Oh, no.
It's so funny.
Hey, wasn't I just talking about how I don't like drawing Christmas
I know,
trees?
you were just talking about Christmas trees, and I see a Christmas tree in ASCII. Okay. Would you like to read day 7?
We should take. I mean, I could just read it out loud, but I was thinking we could just we could take a minute here.
Okay.
Pause, read it, and then I'll recap it.
Okay. All right. We're going to take a break now. We'll be right back after we read day 7.
All right, so we have taken a look at problem 7. Here's basically the gist. It's called laboratories, and we are apparently going to help with teleportation. But there's an error, and the error code is, oh no, 08N0. Love that. Mm-hmm. There's a problem with one of the tachyon manifolds. We have to reverse the polarity, and then an analogy about it spoiling the mother's milk or something, if I continue the Star Trek technobabble.
Oh, dear Lord, please don't.
Basically, we get a grid, it looks like, a diagram. And in the top row, there is the letter, it's a bunch of empty spaces and then the letter S. Mm-hmm. And then below that, the empty spaces are also met with carets, you know, the little up arrow looking thing, Shift 6. And those are splitters. And so what we're supposed to do...
They even kind of look like splitters.
They do.
It's like going...
Is the S... Let's see. The S is the starting point.
Mm-hmm. Where the tachyon beam goes through.
That's where the tachyon... Yeah, that's the tachyon beam entry point. Mm-hmm. And then it shoots downward. And then when it goes downwards, it can go through empty space, no problem. But if it hits a splitter, the beam stops, and a new beam comes out from both the left and the right of the splitter. Mm-hmm. And I can already see where this is going to cause a problem. And then that just continues down. And one of the things to note here, I think, is if 2 splitters create a beam into the same spot, splitter, space, splitter, right? The first splitter is going to split to the left and right of itself, the right of which is the left of the next splitter. Mm-hmm. So the 4 beams it creates are actually only 3 because the middle one is shared. I have a feeling that's going to be part of the problem here. Continues until all the tachyon beams reach a splitter or exit the manifold, and our input is the manifold. Let me look at my sample input. It doesn't look like anything crazy. It is...
Looks like a Christmas tree,
but
it's not.
Yeah, it looks like a giant triangle. Looks like a Mandelbrot set.
Yeah.
Or no, Sierpinski gadget. That's the one. One of the chaos theory things. I think they were kind enough to never put 2 carets next to each other.
Oh, really?
2 splitters immediately next to each other, because I don't know. There's no rules for how to handle that. So if you split into a splitter,
I see what you mean. Yeah,
so that's good.
I think you're right. Yeah, they always have a space in between them. That is key. So you're really worried about the overlap of beams. That seems to be the issue here.
I'm not even a tachyon beam is actually not necessarily. I have a feeling that'll come up in part 2. In part 1, we're trying to repair the teleporter. And in order to do so, we first, part 1, need to understand the beam splitting properties of the tachyon manifold. And in this example, a tachyon beam is split a total of 21 times, which I don't think is the number of
splitters.
I'm hoping is not the number of lines. It's one.
It's also not the number of splitters. Although, is this just a math problem?
Shouldn't it be?
Is it just? No, it's actually there's 22 splitters, unless I counted wrong. 1, 2, 3, 4, 5, 6, 7, 8, 9 in the sample. 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 20.
Oh,
there's 22 splitters.
It's because only one of those. Nope, that still doesn't make sense.
No, because each time it hits a splitter, it splits.
Yeah.
So why wouldn't it equal the number of splitters?
It's a good question.
It's the number of splitters minus 1.
But why? And is it? Or are we just getting lucky there? And I bet this must have something to do with the overlap. The overlap happens a couple times, though. Several times.
I mean, the overlap happens on the second level of splitters, because it says the 2 splitters create a total of only 3 beams since they are both dumping tachyons into the same place between them. Right. But it's still split twice. 2 new beams are emitted from the splitter. So we're just doubling the number of
split here.
Beams plus 1 from the original one. Just for the folks at home.
This makes no sense.
Yeah, this is not a great puzzle to do on an audio only thing, because this is at least I think it's a very visual problem, but I'm thinking, like, is this just a math problem? Is this just a split minus 1? If it is just the number of splitters minus 1, which I'm sure it's not that simple, like, you could just loop through the input and count all the splitters and minus 1. But I'm trying to understand, even on the sample, why it's 21 and not 22. Because it splits. It splits at every splitter, doesn't it?
I would think so. That's what I'm trying to figure out.
Unless
the original beam stops and 2 new beams are emitted. But in the case where they collapse, at this point, 2 bitters create a total of 3 tachyon beams. So are we saying how many beams get created at each splitter?
That's not what it's asking.
It's 1, 2, 3, 4, 5.
It's not how many times will the beam be split. It's how many times, it's how many times the beam will be split, not how many beams are made. Because that's where you would care about the overlap.
I want to know how many splits are we saying are happening on that very first one? Is that 1? The incoming tachyon beam extends downward from S until it reaches the first splitter. At that point, the original beam stops and 2 new beams are emitted from the splitter. Okay, and then down at the bottom, a tachyon beam is split a total of. Is it saying how many the maximum times a single beam is split? Maybe 1, 2, 3.
But then it should be way less than 21 because there's multiple overlaps. We are currently looking at I'm looking at the current sample end product after you shoot the beam and it goes through all the splitters, and I'm going through each split to see where maybe there's a point where a splitter doesn't actually do any splitting because the beams are so close to each other that no splitting needs to happen, or something weird like that.
That's my guess. I was looking for one where a beam already exists on both sides of it. Like, where did this beam come from? Like, there's that section in kind of the middle of it where you get like 3 beams in a row.
So if you look at row 1, 2, 3, 4, 5, 6, 7, where you get the first triplet splitter, the middle splitter and the beam on the right travels all the way down to the bottom without ever hitting another splitter.
Right, so that beam never gets split.
It gets split once, but it doesn't get split.
Okay, so the first one, we have a split. And then each of those gets split themselves.
Mm-hmm.
Let's focus on how we're going to parse this thing.
Okay.
That maybe is the first problem, right? So looking at this, I mean, it seems fairly straightforward to parse, right? We've got splitters, and we've got empty spaces, and we've got tachyon beams. Those are basically the 3 things we can have.
Mm-hmm.
Because the S is its own tachyon beam. Point.
I mean, are you thinking that we need to make a grid out of this, or is that not necessary for...
So that seems like the obvious answer, and I'm wondering how we want to... Yeah, maybe that's it. We just dump it into a grid, And then from there, I guess you just go row by row and
update the data
what's gonna happen.
as the beam goes
like,
down.
all right,
Yeah.
I'm in this row. There's nothing above me. Great, I don't change. Something is above me. Great, what do I do? Oh, there's an S. Oh, I turn into a beam. And then the next row, I go down to it, and there's a caret. Okay, the guy to my left needs to become a beam. The guy to my right needs to become a beam. And then the next one, oh, there's a beam above me. I become a beam. There's a caret above me. I don't do anything. There's a beam above me. Blah, 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 blah. And so, like, we could keep going through and parsing.
And I mean, then we would just get, an internal model of what we're seeing in the input, but I'm not sure how that...
Well, I'm wondering if we start counting, like, how many times a beam gets split that way. Like, isn't it possible that some splitters wouldn't even be hit? I mean, they're all hit here, right? Oh no, there's a beam there's a splitter that doesn't.
There is a splitter that doesn't get hit. So wait, but
okay,
so that's just
we know why it's 21 now.
Yeah, so that's just counting whether a splitter has a beam above it or not.
Yeah.
So you just go through
you process,
and
and then go through and okay, that seems straightforward.
Okay, I'm glad you pointed that out. All right, so you just go through. So you make a grid and then you follow the grid through and you do exactly the logic you were going to say. But you really only care. I mean, you care about making the beams, but you also keep track of like, oh, I found a splitter. Is there a beam above it? Then add that to a total. And then once you get through the whole thing, you find out what that total is, and that's your answer.
Yeah.
That sounds right.
Okay.
Okay.
So I think we can try that.
Okay, so I'm curious, like, let's just backtrack a little bit here. Like, we're doing a new puzzle, and I'm interested in how you start a new puzzle in, Vim. Like, what is your process to create a new puzzle for a day?
Yeah. So I have a script called generate that I run, and it looks at the date, and if there's no current folder with that same date in it, then I copy over a bunch of files and make some minor modifications to them. So the first thing I do is I run that. The next thing I do is I copy in the sample data into a file called sample.txt, and then I copy the real data into a file called input.txt, and then my template already knows what to do with that stuff. Like, it knows first pass through, look at sample, second pass through, look at input. So what I'm doing right now is I am going through and I'm copying those in. What about you? What do you do when you first start?
Yes. I also, at this point, have a script that I wrote that does pretty much everything you said, that looks at the date and makes a directory in the public/puzzles/year. Like, basically, I do ./gen, the year, and the day. And then it parses that and creates the directory, and it creates 4 files. It creates the actual code file for whatever language I'm doing, and I have kind of like a master list of the language of every year. So if I give it 2020 whatever, and it looks that up and it says, oh, you were doing that in Ruby, then it creates a daynumber.ruby or .rb file. And then it also creates the day.sample1 and the day.sample2 and the day.input. And then I go to Advent of Code and I copy the sample data into those and the input data into those. And then, yeah, just like you, at the end of every template, no matter which year, I basically found whatever the colorize plugin is for that language so that I can print it out nice and pretty so it's easier to tell, like, part 1 is in blue, sample is in yellow, and input is bolded yellow. So just
I have colors, but I don't use any of them. Like, I have a tool, like one of my utilities is for producing colors, but I never end up using it.
I love color. That's just something I've noticed, like, over the years, that, like, I love to use color, especially in a command line, to help differentiate things. And I've noticed that in a lot of plugins and packages, they've gone from being just black on white or white on black to actually using color for various things to distinguish certain parts of the output from others. I find it really helpful. So yeah, I use that all the time. And then I go in and, at least for this year, basically reading in the input, because it's always a text file, I just go to one of my earlier ones and I grab the same kind of loop that basically does a 4-line in input : lines function, and that just goes line by line in a file, and then I process the line however I need to put it into a data structure that I can then work on. And since this is a grid, I'm going to go back to day 6, because that was a grid, and do and create a 2D grid out of this.
So when I'm doing that, the way that looks like for me it, like the actual creation of the grid, or actual parsing is I enumerate over the lines, and the enumerate function in Python spits out both like the index and the value. So then I call the index y, because that's the y. I guess I could call it call. That would actually make more sense now that I think about it.
I've tried to do row call over XY just because not every language and not every system.
Yeah.
Yeah.
So I iterate over it that way, and I use those when I'm creating my grid. I realize, though, the first thing I have to do is I have to figure out what my width and height are going to be.
Now,
My grid, because my grid requires that.
Now, why does it require that and it doesn't just read the length of the file and the line to know how wide and high it needs to be?
I mean, that's where I'm getting it from.
Oh, okay.
But like my actual grid class, why does it need that? That's a good question.
Because I create my grid by basically creating a new table for every row, and then I go character by character in the string of the line and insert that character into that table or array.
Yeah.
But I don't do anything about the width and the height. It goes as long as the input is.
I like to know what the width and height are for the overall grid. I guess I could figure it out at the end, like what the maximum width and the maximum height were, so that I know what's in bounds.
Yeah.
It's specifically for that. So the width is easy, or so the height is easy rather, right? And
Number
that's
of lines.
the length of the input.
Yeah.
Then the width is the length of the first line. That's how I usually do that.
Yes.
Now, that can get me in trouble, but currently is not.
Well, yet that was trouble for me on day 6 because when we were doing the cephalopod math,
Yep.
I had to specifically find the longest line to be the width of the table so that I could line up the grid right. And I will say that I just went into my input and I looked at the last number in every line, and I noticed that at least in my input they were all 2 digits, so it didn't matter which one. But if one of them was 3 digits, then you would need to specifically choose that one. Otherwise, your grid would not be wide enough. And just so you know, I've gotten to the point where I can now run my solution, and it pulls in the grid, and I see the exact same thing as the input on the Advent of Code site, all nicely formatted.
So that is what I'm expecting to see when I run this right now. Oh, it's another thing I did on my templates is I finally wrote a debug print class with log levels and everything.
Isn't that something Python already has as part of some package or whatever?
It might, but
you
I
have to
didn't
write
know it,
yourself.
so I wrote my own.
Of course. And what exactly are you debugging, or you're not debugging yet?
I'm just printing out right now I'm just printing out the grid.
Okay, yeah.
It's complaining about my logger, oddly enough.
You mean the thing you wrote?
Yeah, let me try this instead. Print data. Okay, so it's a problem with my grids string class is actually what I'm running into here. Or my string, the grids string method. I have a bunch of lint errors. Let's find out what it thinks.
Oh, well, that's what it's supposed to do.
So these are the problems I run into more often than not.
Oh, sure. Yeah, this is just programming.
It's not a problem with the actual class.
Right. Just getting the basic thing to run so you have something you can look at and analyze. Yeah.
So the problem is that it doesn't think that one of the indices is there.
But I assure you it is.
I would think, unless I mess something up. We're going to go old school debugging, and I'm going to just print stuff out.
Oh, that's current school. I still do print statements for most things.
So it's looking for 16 for some reason.
I'm also thinking, like, can this be done in a one? I'm sorry if I'm jumping ahead, but can this be done in a one? Like, once you create the grid, my next thing is that I'm going to, loop through my grid to check for things. But obviously, the input data does not have the tachyon beams yet. You have to create the tachyon beam so that you can then analyze whether it's split or not.
Exactly.
Is this a one pass, or do you think this is a 2 pass?
I think you could theoretically do it as a single pass.
But is it worth it?
I probably would do it as 2 just to not have to think too hard about it. In particular, because this puts us in a situation where we're adding... I would have to put into a special case where when it's a dot, I ignore it on input because I might have already written a beam there. I think it's this one. So I think what's happening here is that my width was including the new line. or not the new line at the end. And so it was trying to.
I got the 2D grid showing because it was basically no different from either day 4 or day 6. And then I created the loop to look for splitters that have beams above their head, not frickin' laser beams. Although no, oh my god, they are kind of frickin' laser beams. All right, I have the check for splits that have frickin' laser beams on their head, but now I'm going back to just add the beams, and so I'm just doing this really, really dumb. I'm just like, I'm starting at row 2 both times, and then I'm checking the row above it, and if it's an S, then the current cell becomes a beam. If it is a splitter, then I add a beam to the left and the right columns, as long as they are not out of bounds. At least in the sample data, that's not a problem, but I'm sure the input has that, and that should be something you check anyway.
Yeah,
and
that's it. My problem was an off by 1 error, as always.
Yep. That there are what's the old joke? There are 2 issues in computer science: cache invalidation, naming things, and off by 1 errors.
Yep. It's a great joke. Love it. Okay, so what we'd want to do is see what I should do is I want to make a class specific, like a subclass of grid that is this tachyon thing, so that it knows how to process on its own, and I don't have to write hard code the code into my solution. But that's not what we're gonna do. Yeah. So then we have to go. So once you put things in your grid, what you do is you're going down line by line, basically inside that grid. Okay, that's what I was gonna do.
Yes.
Column.
And I'm just, and there's basically 2 checks. There's, and honestly, like, you could almost start at the 3rd level, because the exception for the S is like a one-time thing, but I'm just adding it into the loop, and I'm just starting at row 2. And if the one above is an S, then that current space becomes a beam. If it's a splitter, then the ones on the side become beams. And that's literally it. And until I realize that there's more, but and just make sure that it doesn't go out of bounds. That's it. Also, just one thing that I've noticed in Lua that's another one of its eccentricities that's, I'm sure it's done this way for a reason, that like you need to build a lot of things that, once again, you might be used to in other scripting languages that it doesn't have built in. Like, you can't even do a num plus equals 1, let alone a num plus plus, which I love to use, but I've compromised on num plus equals 1 because that seems to be
because it seems to be more universal. Yeah,
the plus plus thing must be like a C only thing, or I don't know. But Lua doesn't do either of those. So if you want to increment a counter, you have to do num equals num plus 1 every time. There is no syntactic sugar, and I'm just like, that's a choice. I'm not sure I would agree with that choice, but that's a choice.
It's a choice. Yeah, I don't like that.
I don't like it either.
I have another off by 1 error, so this is fun.
All right, let's see what insanity happens when I just run this without double checking any of this.
For me, so far, it's been a bunch of errors.
Oh my god, I got the sample answer. What is happening? Okay, but I'm sure, and what I always do is, on all my templates, I always have like a line that does it with the sample 1 for part 1, and then it does it with the input, and then it does sample 2, and then input. But I usually turn off the input because that's usually the crazy data that doesn't work yet. But now I'm turning it back on, so it runs it, and it ran it pretty instantly and gave me a big number. And now I'm like, do I just submit it? I don't know. I'm scared.
Oh my god, I know what I'm doing wrong.
Okay.
That's stupid. Okay. That should have thrown a warning of some sort in here.
Like in Python or in your code checking?
The lint should have thrown an error, I'm pretty sure.
Okay. I'm submitting this just so everybody knows. I'm scared, but I'm going to submit it, and let's see what happens.
You're already further than I am. Let's see it. Maybe you'll get it. Then you can.
Oh, not the right answer. Answer is too low.
Okay.
Okay.
It's so much fun. All right.
I know, but that makes me... Now I have to actually think about it.
So let's see. At gets cells at position. Position is a tuple. Set cell. Oh, set cell is not a tuple. There you go. So part of my problem here is I think I am not being consistent in my grid class with how I am referring to a position. Mm-hmm. I know I didn't change any code here, but let's run it again and see what happens. It's always a good sign when I'm doing that. So for some reason, I am failing to write out my entire string.
Okay, so I should have looked at the printout of the beamed version of the grid because I now see why it's too low because it's... What's weird is that I got the right answer for the sample, but when I look at the grid, it does not match the sample grid with all the beams. So I don't know... That was just a happy accident, and I hate it when that happens. I hate it when you get the right answer for the sample, but there's this potentially huge chasm between the sample data and the input data in terms of like what you're accounting for. So now I have to go back and figure out why it's not putting the beams where I thought it was putting the beams.
I am losing. I am for some reason not capturing one of my inputs at all. And it's just not there. Like the last.
Well, that sounds like an off by one issue.
Yep, as it is. Oh, wait. Oh, haha. I got my rows and columns reversed. That's what I get for switching from XY, which I understand, to row column.
Yeah.
Which my brain doesn't naturally get.
Well, and okay. I intuitively think of a grid like math class where you go from 0, 0, X over and Y up. But when you're thinking about advent of code, it actually makes more sense to start at 0, 0 at the top left and go down rows and over columns.
Which also often throws me off.
Oh, okay.
It was not right before.
Yes, I did forget to account for if there is a beam above you, make this a beam as well. That's probably where I messed up. You even mentioned that when we were talking about it, and I didn't think about it. Yeah.
Well, only if what you're currently on is not a beam, or it's not a splitter, because then that is different.
Oh, you're right. It has to be, the one above has to be a beam, and the one you're on has to not be a splitter. Okay. I feel like I might have fixed the order of how I'm checking might have accounted for that, but it's a good idea to put that in there anyway. Well, that was adding that in definitely messed my grid way up. Although honestly, like for me, it's much more fun when the task you're trying to do is to get like a visual to print out in a way that you expect, rather than just like an arbitrary number, an integer of some size. Like that's not as exciting to try to get right, but like tinkering with this to make all the lines appear logically how you want is more fun and engaging for me, at least. I don't know about you.
I tend to agree. And I think I see where I'm getting my problem, which is my usual problem of if not line, continue. Because the last line in my input always seems to be coming out blank lately. Even though I'm not putting one there. Nope, that wasn't it either.
I wonder if I need to do like a... Maybe this is more of an else if thing. I feel like the order that I'm doing these checks in is definitely throwing off something. So let's try that. Did that do it? No, that didn't. Oh yeah, I forgot to mention on day 6 that I actually used a goto in Lua. Because
you said that online.
Because they don't have a concept. Lua doesn't have a concept of continue. Like if you're in a loop but you just want to skip to the next loop because of whatever reason, it doesn't have the idea of a break or a continue and then go back through the loop again. Like it has a break, but that just breaks you out of the loop entirely. And once again, you probably could rewrite your code in a way that gets around that, but I actually saw someone suggest, oh no, just use a goto. So I just put a target of like skipped here at the bottom of my loop, and then when I got to that condition where I wanted to skip and go to the next one, I have a go to that label. And I felt dirty and weird and wrong, but it worked. So, oh well.
Yeah. Hey, I don't think there's anything wrong with that.
Okay. Right. No, if the one above it is a bar.
That is our half-hour time box.
All right. Well,
we didn't get very far, but it was interesting to try.
Yeah,
So I'm running into problems entirely on my something weird's going on with my parsing that I'm just either my width or my height is wrong, and I don't know why, or both.
So you can't even parse the data and print it out as a grid, or you can't even parse the data?
I can, but then when I try to go and look at all of the items in it, I run into problems. Like I'm parsing it seemingly fine, but somewhere I'm getting the width or the height wrong, and I can't figure out which one yet. So this is one of those stupid errors where I didn't even get to the actual problem before I ran into the problem. And this is just probably something I need to clean up in my code. Would be my guess.
I am sorry to hear that, but it is unfortunately common where you're working on one of these things and you just get stuck in this like local minima of trying to figure out some related but not really like it's something that should just work so you can move on to the actual problem, but it doesn't work, and so you have to spend a non-trivial amount of time figuring out why that one thing won't work. And like, I swear it just worked in the last problem. And it's annoying and frustrating, but it happens all the time. I mean, like, I think, I was spending some time just trying to get, I had written this grid display class in Ruby for a previous year, and I wanted to use it in Lua. So I was using an LLM to translate it. And I kept needing to like tweak it and tweak it and tweak it. And then I didn't even use it because it wasn't useful for that whole cephalopod thing. But having a nice two-dimensional grid display method is helpful to look at, especially when the data is small enough. I mean, not so much on the inputs because they're usually so huge, like the graph is off the screen. But yeah, you can just spend hours just tweaking that to work properly and not even work on the problem, which is annoying. But just to reiterate where I was able to print out the grid. I am able to loop through it and change the data, but my logic for changing the data to insert the beams is wrong, and I'm getting some wild-looking grids that are incorrect. So I'm going to spend time just adding the beams properly because the check for the splits seems to work. If it is simply the splitter doesn't have a beam above it, then it didn't get split. It works for the sample. It runs on the input. It just was too low because I think because the beams were not being put in properly on a bigger data set. They were fine. What I don't understand is why I got the right answer for an incorrect beam addition into the grid. So that must just be a weird happy accident that it was the same number. But when you have a big data set like the input, it's going to be off and wrong. And so that's what I'm going to have to work on. But I think we at least figured out like roughly what we need to do. Like we grok what it's trying to get us to do, and we have an idea of how to solve it, which is good. Makes me worry about problem 2. That would be actually an interesting question. What do you think problem 2 is going to be?
I think...
Or part 2, sorry.
Part 2, it's likely to be... So we're splitting them 21 times. So what we need to find is the total number of beams created.
Yep.
Is going to be my guess. But that's too easy, because then you would just read all of the pipes.
No. Not how many beams are in.
Oh, how many beams are created?
Created.
Because then we can't. If the one above you is a line, it doesn't count.
Right.
Yeah.
The overlap. So wait. So I'm curious. Does that mean that you were going to write your part 1 to allow for that before you even open up part 2, or are you going to wait to see?
I'm going to wait to see. I am going to keep it in mind as I go.
Yeah.
So I figured out what the width and height should be in my code, but for some reason they are not. I hard coded them, and then things started to work.
Sometimes you got to hard.
Yeah,
code.
I'm gonna take it into account. I think I'm already looking at what I'll probably do as I go through is like make a note of like created a beam, and like just put a comment there so that when I get to that point, and that is what it turns out to be for part 2, I just run it. So I guess we'll find out how we did in our next episode when we recap the final 6, including this one, problems for Advent of Code 2025.
Yes. The next time we come back, we will tackle how we did on this one and the final 5, yes. But I believe for this episode... that was our attempt at doing day 7 in 30 minutes. I think we got farther than I thought. I didn't think I would get as far in the code as I did, but
I expected to get about as far as you did, but much further than I did.
Yeah, but like I said, this happens all the time. Where like a thing that you think should just run and work because it's worked before somehow doesn't work, And now you have to spend your day debugging that, which is not super fun, but sometimes it's got to be done. So, but yeah, I think that'll do it for this episode of Hacking the Grepson. Thank you for joining us on this live coding edition of Advent of Code. And if you want to listen to more of our episodes, you can find them at hackingthegrepson.com, where we have tons of Advent of Code talking episodes, and you're welcome to listen to them. And until we next speak at you, if we don't speak to you again before the end of the year, happy holidays, Merry Christmas, Happy Hanukkah, all those things. And
Kwanzaa Festivus.
My
birthday, your birthday, all the things.
Yeah, happy birthday, Matt. Happy birthday to me.
Happy birthday, Mike.
Thank you. And we now return you to your regularly scheduled lives already in progress.